Hi there, welcome back to another video from the Math Doc. This is our second video on percent proportions. In the first video, we looked at what a percent proportion actually is. We looked at quite a few examples, and in particular, we kind of identified the way things look when we use percent proportions, that we have usually words that are identified that identify the different parts of the proportion. We either have part of a whole, or we have is, a ratio of is to of. And in these word problems that we will try to solve in this video, we will identify the words as well. So if you need a refresh, go back to that video. You can watch just the beginning or a couple of the examples, and then come back and let's go through these word problems. So this first one really practices percentages, and it's kind of straightforward. So we have a table here that shows the average number of hours that different age groups spend sleeping. So for a newborn, we see there's 20 hours. So a newborn will sleep on average 20 hours in a day. A toddler will sleep 15, a preschooler 13 hours, a preteen 11, and a teenager on average 8.5 hours, although they probably need more than that. So the question is, what percent of the day does each age group spend sleeping? So let's first identify, in this formula here, what our part and whole are. So what percent of the day does each age group spend sleeping? So our part here is, the part of the ratio is just the hours, number of hours sleeping, right? And the whole here is the number of hours in a day, which is just 24 hours, right? So it's quite simple. It's, if we look at the newborn, so we have to take the ratio of part to whole, so that would be 20 divided by 24, that is our ratio, equals the percentage in number divided by 100. So what is 20 divided by 24? Well, we have to add a 0 here, right? And add the decimal point there. So 200 divided by 24. I think 24 goes into 200 8 times. Let's see, 8 times 24, that's 8 times 20 is 160. 8 times 4 is 32, so we have 192. So indeed it does go in, and 200 minus 192 is just 8. Again, we'll add a 0 and move over to the next point in the decimal. 80 divided by 24 is just 3. It goes in 3 times. 3 times 24 is 72. And we have another 8 here. So it'll just go on. It'll be 0.8333. So 20 divided by 24 is 0.833. So 0.833 equals percentage divided by 100. So how do we figure out what the percentage is? We multiply both sides by 100, right? If we multiply both sides by 100, we get 0.833 times 100 equals percentage, because the 100 divided by 100 cancels. 0.833 times 100, we just have to move our decimal two places to the right, and we have 83.3 is the percentage in number of the day spent sleeping by a newborn. So here we have 83.3%. Okay. For the toddler, now we have 15 divided by 24 is our new ratio of part to whole, right, of this part of it. And if we do 15 divided by 24, we'll get, this is just equal to, I won't go through this too slowly, but this will be equal to 0.63. And so in terms of our percentage, again, we just have to move two decimal places over to the right, and we have 63%. For our preschoolers, our ratio is 13 to 24, right? That's the part to whole, and that is just equal to 0.54, and I'm rounding it up here, 0.54. Again, to get the actual percentage, we will be equating it with the number, with the percentage divided by 100, so we have to multiply by 100, and we get 54%. For final two, we have 11 hours. 11 hours ends up, so we have 11 divided by 24. That's already less than half, right? Because 12 is a half of 24, so we know that'll be less than 50%. 11 divided by 24 is just 0.46, so we have here 46%. And for the final one, we have 8.5. 8.5 divided by 24 is equal to 0.35, so we are left with 35% here. So we can see how, as children grow up, the percentage of their day that is spent sleeping goes down. We could graph that if we wanted, but basically that is the solution for this problem. So now if we want to write up one of these as a full sentence solution, let's look, say, at the toddler. We can say that on average, a toddler spends 63% of their day sleeping. And that is the answer the full answer to this type of problem. So let's move on to another slightly more complicated problem, another word problem dealing with percent proportions. This one is going to be a little more complicated because we're going to have to take an extra step or two. But again, I think this example will actually really explain the use of the percent proportion. So this is a baking problem. A typical bread recipe includes flour, water, and a tiny amount of yeast and salt with a constant ratio of water to flour. So usually bakers have a constant ratio of their water to flour when they bake bread. In this problem, for plain white bread, our baker uses a 3 to 5 ratio. So it's a ratio of water to flour, which is 3 to 5. For pretzels, which are kind of harder and drier, there's less water, and the ratio is 2.75 to 5. Sorry, 2.7 to 5. So let's go ahead and answer the first question, which is, what is the percentage of flour in a plain loaf? So in order to figure that out, we have to figure out what our part and whole are in this formula that we have for the percent proportion. So we're looking at the percentage of flour in a plain loaf. So it looks like our part, right, is the flour. It's the amount of flour. What is our whole here? Well, our whole is the entire loaf, right? So the whole is flour plus water. Okay, so let's look at our ratio here. Do we know either one of these? Do we know what the part is or the whole is? Well, not quite. What we have is a ratio between the flour, the water and the flour, not a ratio between the water and the whole weight of water plus flour, but actually a ratio between the two. So we still have to figure out that first step. How do we get to the whole? Well, let's look at this. We have a ratio of 3 to 5, right? 3 water to 5 flour. So let's take this ratio and see what our whole would be. If we did have 3 parts water that would mean 5 parts flour. So our whole weight would be 3 of the water plus 5 of the flour. So in this case, our whole would be 8. So now what is our ratio of flour to the whole? Well, our flour here is 5, right? Because we have more flour than water. 5 to the whole is 8. So our ratio is 5 to 8. That equals the percentage in number divided by 100. Okay, now, so how do we translate that? How do we solve that? Well, let's cross multiply here. So we have 5 times 100 equals percentage times 8, right? Where here the percentage is really the percentage in number. And let's divide both sides by 8, right? So that we can isolate our percentage. And we have now 5 times 100 divided by 8 equals the percentage. Basically, we have the percentage equals 500 divided by 8. What is 500 divided by 8? Well, let's do that on the side here. 50 divided by 8 is just 6. 6 times 8 is 48, right? So we have 20 here. We have 2. We bring down our 0. 20 divided by 8 is 2. 2 times 8 is 16. We have 4. Let's add another 0 and move over. Put in a decimal point, and now we have 40 divided by 8, which is just 5. So our percentage is 62.5. So the percentage of flour in a plain loaf is 62.5%. Okay, running out of space here. Okay, so now we have the percent and we can work with that. Now the question is, how much flour does the baker need for a 1 kilogram, that's just 1,000 grams, loaf? So if we have a loaf that weighs 1,000 grams, that means our whole now, right? The whole is equal to 1,000. And we're asking how much flour did we need? Well, we know that the percentage of flour is just 62.5, right? So now we have how much flour, that's our part, divide by 1,000, the ratio of part to whole, equals 62.5 divide by 100. That's, again, we're using this formula here. So what is our part? Well, let's multiply both sides of this equation by 1,000, okay, so that we can isolate part. Part equals 62.5 divide by 100 times 1,000. Well, luckily for us, 1,000 divided by 100 is just 10, right? We can cancel that, and this is equal to 10 times 62.5, which is just 625. And again, this is flour, and this is grams, right? So now we can say that we need 624 grams of flour for a 1 kilogram or 1,000 gram loaf. Now there's a follow-up to this question that has to do with the pretzels, okay? Remember, we have the pretzels here that have a slightly different ratio of flour to water, right? Or of water to flour. The ratio there is just 2.7 to 5. So what is the follow-up? Well, with the same amount of flour, remember how much flour did we actually end up with? We ended up with 625 grams. Let's write that down, 625 grams here. with the same amount of flour, how much pretzel dough can the baker make? Well, how do we figure this out? Well, first of all, we have to figure out, again, the ratio of part to whole, because we do have the ratio of water to flour, right? That we said was 2.7 to 5 in this case of the pretzels, but we still need to figure out, first of all, we need to figure out the ratio of flour to dough, and then we can go ahead and figure out how much 625 grams of flour will make us. So let's look at that again. How do we do that? Well, again, if we have 2.7 to 5, that's the ratio of water to flour, we're looking for the ratio of flour to dough, and we will just add up the flour and water to get the size of the dough. So again, here we have the flour to dough, and this is our part to whole, equals the flour is 5, and the dough is just 5 plus 2.7, that's 7.7, right? And that should equal the percentage in number divided by 100. And we can do this with a calculator, and if you do that, what you find is that the ratio of 5 to 7.7 is just 0.65. Okay, so that's equal to 0.65. So what does that mean about our percentage? Well, we multiply this by 100 to get the percentage, and we find that the percentage is just 65, right? So in this case, the ratio of flour to dough is 65% divided by 100. Okay, so now let's figure out what happens when we have 625 grams. So we have 625 grams. The ratio of that to the amount of dough, and I'll just write our variable as dough, is equal to 65 divided by 100. How do we figure out what dough is? Well, let's cross multiply, right? We have 625 times 100 equals 65 times the amount of dough. And now let's divide both sides of this equation by 65 so that we can isolate the dough. And the 65 here and the 65 here cancel. And 625 times 100 divide by 65 is equal to the dough. And again, let's use our smart calculators, and what we find is that the amount of dough is just, when you do 625 divided by 65, that's a little less than 10, right? Because it's 625, not 650. If we had 650 divided by 65, we would just have 10. So it's less than 10 times 100, so it's just less than 1,000, and actually ends up being 962 grams. So that's the amount of dough we can make. We can make 962 grams of pretzel dough. So the 625 grams we got from a kilogram, 1,000 grams of bread dough. Here we're making pretzels, which are a little drier, so we have less water and we end up with less dough. So we end up with 962 grams of dough. And another follow-up to the question is, well, if each pretzel weighs 30 grams, if the baker makes pretzels that weigh 30 grams, how many pretzels can the baker make? Well, we have 962 grams of dough, of pretzel dough, and since each pretzel weighs 30 grams, let's just divide 960 by 30. How many times does 30 go into 9? Well, it doesn't, but then let's use 96. So 30 goes into 96 3 times. Let's do 3 up here. 3 times 30 is just 90. And we subtract and we get 6, right? We'll bring down our 2 here. How many times does 30 go into 62? Well, it goes in twice. 2 times 30 is 60. So we have 2 here. We can add a 0, and we'll have 20, and we'll put in a decimal point, and then we have to add another 0 here because 30 doesn't go into 20, so we'll add a 0 here. How many times does 30 go into 200? It goes in 6 times. So 6 times 30 is just 180. And again, we're left with 20. So we're looking at 32 plus a remainder. So we can make 32 whole pretzels, right? 32 pretzels. And we have a little bit of dough remaining, just about 0.6 grams, so not enough to make anything substantial. So the answer is 32 pretzels. So that brings to an end this video on percent proportions. Please let me know if you have any questions about this video. I'll be happy to clarify, to look at additional examples. Just include those in the comments. If you'd like, please subscribe, like this video, and please come back for our next time. Okay, see you then.